We got a good little lesson here today. Got some good news and some bad news. The good news is we don't really have to learn anything new. And I guess the bad news is that the only thing in this lesson are proofs. And let me tell you why. Because what we're doing today is we're going to go one step further. After we prove triangles are congruent, we're then going to prove some other parts of the congruent triangles are congruent. And we can really do that because that's the definition of congruent figures, right? Is that all corresponding parts are congruent. So let's look at this definition that we have here. By the definition of congruent triangles, if you know two triangles are congruent, then you know that every pair of corresponding parts is also congruent. When using this knowledge in a proof, we abbreviate it as Cpctc. And what that stands for is corresponding parts of congruent triangles are congruent. So let's just look at how we use this in some proofs. And just so you know, every one of the proofs in the lesson today, I've already gone ahead and made my columns and written down my first statement and reasons which are given. So if you want to pause here and do that, it'll make our lesson go a lot quicker. Okay, so the first proof we have here, right here, we're given that SD, so I'm going to highlight these things that are congruent. SD is congruent to TC, and CS, let me grab another color, CS, this piece over here, is congruent to DT. And what are we trying to prove? We're trying to prove that angle SCT, so let me get yet another color, angle SCT, so that would be this little angle right here. We're trying to prove that that's congruent to this little angle over here, angle TDS. So our approach for this is going to be to prove that the two little triangles, this one here and this one over here, are congruent to one another. And then once we've proved them to be congruent, we can say that those two little angles are congruent because they're corresponding parts. So how are we going to show that these two triangles are congruent? Well, we already have two sets of corresponding sides, right? So if we look at this right here, let me pick another color, maybe purple. If we take this side right here, TS, that's contained in both triangles, right? It's a side in both triangles. So what we're going to do is we're going to say that TS is congruent to itself. Remember our old friend, the reflexive property? Reflexive property of congruence. We can say that side is congruent to itself, and then we have it, right? We can say triangle SCT is congruent to triangle TDS by side, 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 right? Side, side, side congruence theorem. All right, so now that we know the triangles are congruent, we're all set to say that those two angles are congruent. Angle SCT is congruent to angle TDS. And how is we know that? Because they're corresponding parts of congruent triangles, and they're congruent. Okay, that's all there is to it. So let's do another one. Again, we got these two triangles here, and we're given that angle WYX, so that would be that one right there, is congruent to ZXY, that one right there. And then we also know that angle WXY, so that's this little one here in this corner, is congruent to ZYX, which is this little one here in this corner. And what are we trying to prove? We're trying to prove that WX, so let me highlight that, this side here, WX, is congruent to ZY. So I'm guessing those are going to be the corresponding sides in those two triangles. So guess what? I've written down the given here. This one is very, very straightforward, very similar to the previous one. So I want you to pause here and do this little proof and then come back and check your answer. Okay, so hopefully you realized that because I've got these two sets of corresponding angles congruent, all I really need to do is see that this side here, XY, is shared between those two triangles, just like, what did we have above here? Just like that side TS was above, and so I have to say it's congruent to itself. And then I've got the two triangles. WXY is congruent to ZYX by angle, side angle. And guys, please remember here, it is very important that you have all the corresponding vertices in the same order when you write this congruent statement for these triangles. So vertex W corresponds to vertex Z, and so forth. The order is very, very important when you're writing your congruent statement for the triangles. Okay, and then once we say the triangles are congruent, we know that side WX corresponds to ZY, and therefore they would be congruent by Cpctc. Okay, here's another proof. Let's see what we got here. This proof could be done in a very quick way, but I feel like since it's in this lesson, we need to go ahead and use Cpctc to do it. So what do we got here? We know that angle GMJ, so this one right here, and HMJ are right angles. Okay, GF, it's already marked here. GF is congruent to HF, and angle 1 is congruent to angle 2. So what are we trying to prove? We're trying to prove that angle GJM, so this little angle right down here at the bottom, is congruent to HJM, this little angle right here. So, so what have they given us? They've actually almost given us enough information to prove that the two little triangles at the top are congruent. So what I'm thinking is we're going to have to show that those two are congruent and then use a corresponding parts to show that the larger two bottom triangles are congruent, and then those two angles GJM and HJM are going to be corresponding parts of those two bottom triangles. So here we go. Let's see what we're going to do. We're going to say, all right, we know GMJ and HMJ are right angles. Therefore, we know they're congruent. So I'm going to go ahead and say that. I'm going to say angle GMJ is congruent to angle HMJ. And how do I know that? Oh, our old friend, the right angles theorem. Okay, but that doesn't really help me in proving that those two... Sorry, I got a phone call there, so I'm not sure what I was saying. But I think probably what I was saying is, okay, those two angles are congruent, but they're not in the two little triangles that I was thinking that I need to show are congruent. But what I do have is the side, GF, congruent to FH. I got angle 1 congruent to angle 2. What if I do this? What if I say FM, that's a shared side in those two little triangles, right? So if I say FM is congruent to itself, reflexive property, then I can say the two triangles are congruent, the two at the top. Triangle GFM is congruent to triangle HFM, and that would be side angle side, right? Because once I show that this side is congruent to itself, that gives me side angle side congruence. Okay, and then how does that help me? Well, how about this? What if I then say that this side here is congruent to this side in the bottom triangles? Let's see how that works out. GM is congruent to HM by Cpctc, right? And then we've already got the two angles. The two right angles are congruent. So I'm almost there. I just need one more thing. I've got a side. Look at this. I've got these two sides. I've got the two right angles. So what do you think? Don't I just need to say JM is congruent to itself? Once again, reflexive property of congruence. And now I know the triangles at the bottom are congruent. Triangle GJM is congruent to triangle HJM. And how do I know that? Once again, side angle side. And so finally, I can say what it is I'm trying to prove, which is angle GJM is congruent to angle HJM because they're corresponding parts of congruent triangles. And I just noticed when I scrolled up, I forgot to put one of my given steps in here in my first statement, that angle 1 is congruent to angle 2. So that's kind of a long-ish proof, but not that difficult. Okay, if you got any questions here, put a star, put a question mark, highlight it, whatever you need to do. If we need to talk about it in class, and we will. Okay, here's another one. What are we trying to prove? We're trying to prove that triangle MYX, so that's this guy right here, is congruent to PYX. That's this triangle right here. And what have they told us? Well, they've told us a bunch of things about the little triangles, these triangles over here. So I think we're going to have to use the same approach that we used in the previous proof, which is to prove those two little triangles are congruent, and then use some corresponding parts from those to show that those two large triangles are congruent. So what I'm going to do is, as you might have guessed, I'm not going to work this problem for you. What I will do, we'll do this first thing when we get to class, so don't let me forget. What I will do is look how they've told us that all these angles, all those angles, NZY, QZY, MXY, and PXY are right angles. So I'm going to give you this hint. I'm just going to go right in here and say all those angles are congruent. Angle NZY is congruent to angle QZY is congruent to angle MXY is congruent to angle PXY. And of course the reason I know that is because of the right angles theorem that tells me all right angles are congruent. So, boy oh boy, I think I already know the two little triangles are congruent, don't I? Let's put that down. Triangle NZY. I covered up my Y, but it's that point where the two sets of triangles intersect. Triangle NZY is congruent to triangle QZY. And of course I know that by angle side congruence. And I put this congruence out here, guys, because in a little bit we're going to do some similarity, a couple of units away, so don't worry about it yet. But some of these same theorems and postulates that we use to show that triangles are congruent will have the same names, except they'll be similarity instead of congruence. So it's not a bad habit to get into, to put that congruence after those. Okay, this is where I'm going to stop. I'm going to leave you with that. We know these two triangles are congruent, small ones. I want you to see what you can do with that to show that the two larger triangles are congruent. We'll go over it next time, and I'll see you then.